In today's lesson, we are going to see a short introduction to the pathfinding through the library that Unity provides. So first of all, download the source code that we are going to use for the current lesson. There are some small changes from the previous lesson, so you will have to download it again. So the pathfinding is a basic navigation algorithm that allows to navigate between 2 points when there is no clear path between them. What we are going to do is to order our player to move to a target position by clicking on that target position with the mouse. We are going to do 2 changes in order to ease the process of testing the whole thing. And the changes that we are going to do are, first, we are going to add a new state in the camera controller called free camera. In this state, the camera is moved independently from the player. The idea is that you can move the camera anywhere you want. So you can click the position you want to instruct the player to go. And the other change that we are going to do is we are going to add another new state in the player script that will be called await instructions. And it's a state where the player will wait for commands. And the player will change to this state when we are switching to free camera state. Okay, so right now what you should do, first start with the new state for the camera controller, detect when the camera has been changed to that specific state, and then instruct the player to switch to the new state await instructions. So go ahead and do it. Okay, and the result should look similar to this. The first that we have done has been to create the new state for the camera controller, free camera, and we have implemented the skeleton. That means a new entry for in the update and a new entry in the change state. The next thing that we have done is just to enable a new case when we switch the camera state. So from third camera, we are going to transition to free camera when we press this key. And the next thing that we have done has been to implement, well, the functionality inside the free camera. That is move free camera and rotate free camera. The move free camera, we have taken the code from player and we have adapted to work in this case. And we're just getting the information from the axis, the key, and getting that information in order to increase the position of the camera to move around. And for the rotate free camera, we have also taken code from player and in order to move with the mouse. And we are changing the forward vector of the camera. Lastly, what we have done is to dispatch a new event. This new event will be listened by the player. Okay, and here we have created the new state awaiting instructions. And for this new state, again, we have created the skeleton, both on the update and on the change state. And in the change state, we change the animation to idle. And we are listening now this new event, event camera switched to free camera, in order to switch the state of the player to await instructions. So if everything is right and we proceed to play, when we switch to the camera, you should get a behavior like this. I am able to move the mouse, I am able to move the camera around, and the player is not going to move because he is now on the await instructions state. In case that you got blocked in the implementation of these features, you have here the code checkpoint that you can download in case that you need it. So the next thing that we are going to do, we are going to download from GitHub this project that it's NAP Mesh Components. That is the solution that Unity provides in order to implement their navigation algorithms. So what you can do is go to this option of code and download as a zip, okay? Once it has finished of downloading, you should decompress and you should take NAP Mesh Components and you should move it to your project, to the folder scripts, i.e. because it's related to the artificial intelligence. Okay? So now that we have our algorithms related to the navigation, we can proceed to edit the level 0 prefab. So go to the editor, drag the level 0 prefab to a scene, and we are going to work on the section of statics, okay? And you are going to create a really basic kind of labyrinth where you would be able to ask the player to navigate through this labyrinth. So go ahead and create the labyrinth, a really basic labyrinth in order to do that. I am going to do it myself, so you have a reference of how to do it. As I have said, we are looking for a really basic labyrinth that allow us to test the navigation tools that Unity provides. So this is the configuration I have done. I have created these walls in order for to be able to test if there is no path between 2 points, to activate and use the navigation algorithm in order to look for a path. Okay, I have also moved both enemies and NPCs outside this labyrinth. So right now we are not interested that there are objects in the way of the NPCs and enemies. Later on we will implement that if an enemy or an NPC finds in its way an obstacle, it uses the navigation tools that Unity provides, but for the moment we are only going to focus in the navigation of the player. So the next thing that we are going to do is in this same level 0 prefab, we are going to create a new empty object that we will call navmesh. Okay, and now it's time to add the component pattern that will allow us to use the navigation functionality that Unity provides. So navmesh surface will allow us to create this information for us to use the navigation component to navigate through the labyrinth. First step that we are going to do once we have added the component is to press bake. As you can see, a kind of blue texture or plane has been placed just over some surfaces, mainly on the floor and over some platforms. This blue texture tells you about the navigational areas. So the navigational system can use these marked blue areas, blue surfaces, for the navigation purposes. Okay, all the blue areas are navigational, so you can if you tell your player okay, go to another place that has this blue shader, he will be able to go to that point. But for example, if you can see, there are areas that are not marked as blue. These are areas that are inaccessible to the navigational components. Why this particular area just really close to the wall, it's not navigational? Because the navigational information takes into consideration that the avatars who are going to use the navigation has some size. This is the size that the navigational algorithm, when baking the navigational surfaces, takes into consideration to consider that, okay, the avatar has this size, so he's not going to be so close to the wall. So in short, the bake button allows us to calculate all the navigational areas. You can also observe that there are also inaccessible areas in places where they shouldn't be. Okay, for example, what you are seeing right now is just a waypoint. This is going to be just destroyed in the moment of the runtime. So the navigational system should ignore this waypoint when baking. Okay, so we need to use the tools that the navigational system provides us in order to ignore some objects. To do that, we need to create layers for all the different elements. We are going to create these layers right here, the ones that I have selected in the slide. So you are going to go to the system, add layer, and you are going to add all these layers. Layer, NPC, enemy, and objects. And what you are going to do is just to assign to the group. You can assign to the whole group the layer. For example, for the enemies, just select the layer enemies, and when the pop-up appears asking you if you want to apply to the children or only to that specific object, you choose to change also the children, and all the enemies will be also on the layer enemy. Okay, you can do the same for the NPCs. Select the whole group where all the NPCs are, select the layer, apply to all the children, and again, all the NPCs now are on the layer NPC alongside its waypoints, in the same way that in the enemy, the waypoints are also in the layer enemy. We can do the same for the objects. We can select the objects, select the layer objects, and all the objects will now be in the layer objects. Okay? So now that we have created all the layers, we can go back to the nav mesh surface, and we are going to exclude the layers we have created from the baking process in order to, for the baking process to ignore all these objects when calculating the navigational area. In order to do that, in the nav mesh component, in the layers, you are going to unselect player, NPC, enemies, and objects. Okay, so the layers that the system is going to consider to calculate the navigational information are going to be these ones. Okay, so if we press bake again, as you can see, now the waypoints don't create inaccessible areas. Okay, they are ignored. These are not waypoints, these are just static objects, so they can be considered as inaccessible areas. So still in the nav mesh surface component, we are going to keep exploring properties of this component, like the property use geometry. Okay, this property right here, use geometry, has two options: render meshes, physics colliders. What does this mean? It means that the nav mesh surface component has the option to calculate the navigational areas through just the rendering information or the collider information. Okay, so right now it's taking the rendering information. So each object that has a render component, mesh render, the navigational algorithm takes it as a part of the calculation of the navigational area. In the case that we choose use the collision area, the change, it seems that there has not been any change, but right now we are calculating the navigational area using the colliders, using this component right here. So the difference is that in the case of using the render, the component mesh render to calculate the whole navigational area, and if we use the option of physical colliders, we are using the collider components of the objects to calculate the navigational information. So still in the nav mesh surface component, we have the option of creating multiple profiles, and we can do that by accessing to agent type, humanoid, open agent settings. Okay, so here we have the option to create multiple profiles. And what's the deal with creating multiple profiles is that maybe you have characters of different sizes, and maybe, for example, a tank cannot go through this area. It's so big that he cannot go through this particular area. So you have the option to create different navigational information maps for different characters. Okay, I am not going to go deeper into this particular area because there are better tutorials out there that will explain you in a better way, but it's good that you know that you have the option. Okay, for our particular case with just the humanoid navigational map, you have enough. So the next thing that we are going to do is that we don't want that our walls to be walkable. In order to prevent that, we are going to use a component pattern called nav mesh modifier that will help us to exclude our walls from the navigational map information. Okay, so first of all, if we don't have the level 0 prefab in the scene, you can drag it. And to all the static objects, we are going to add the component pattern nav mesh modifier. So select all the static objects and add the component nav mesh modifier. The component not mesh modifier has the property ignore from build. That means that everything is being ignored in the calculation of the not mesh. We are not interested in that because we want still that these objects get into consideration when calculating the navigational area. But we are going to be using the property override area to true. And now we can decide if all these objects can be walkable or not. As you can see, we have here three options: walkable, not walkable, and jump. And what we are going to do is for these objects, we are going to set them to not walkable. So now, when we go back to our navmesh component and press bake, as you can see, now the blue plane that show that the navigational area has disappeared from that static objects. These static objects are no longer part of the navigational area. So now what we can do is just to override and apply all the changes to update our prefab. So now that we have finished with the calculation of the navigational area, it's time for us to use this system. So in order to use it and to be able to tell the player where we want him to go, we are going to add to the player the component nav mesh agent. Okay, so go to the project, to the player, and add the component nav mesh agent. Now we are going to access the component in the script player. So go to the code, and in the player script, you are going to create a new member variable that will make reference to the navigational component that we have just added. Okay, so add the component, import the necessary libraries. In this case is Unity Engine I. Okay, and now just retrieve the component. So just do it. So on the start, we are trying to retrieve the navigational component. If it is there, this variable member is not null. If it is not there, this variable member will be null. Before continuing, we are going to do this change. We are going just to disable the navigational component in the change state for all the states except for the await instructions state. Okay, so we are going to change in all the states in the method change state in that particular moment when we are transitioning from one state to another. In that particular moment, we are just disabling the navigational component except in the await instructions. In this state, we are going to use the navigational component. So the next step is to tell the player what is the destination position we want for him to go. And to do that, what we are going to do is calculate in what position our mouse collides with the floor. In order to do that, you are going to take the lead and you are going to search for this particular search, mouse collision ratecast unity. And what you are going to do with that information is just to create a function called get collision mouse that will return the position collided by the mouse. Okay, and make this method an static method inside our file utilities. Okay, because then we can take advantage of it to use it in multiple places. So go ahead and do it. And the result should look similar to this. we have created a static function that will return a vector 3, and we are getting the raycast point collided by the position of the mouse. Okay, we usually get the ray, and then with the physics we make a raycast with the ray, the heat information, and to the infinity. And if there is a collision, we will return the position of the impact. If there is no collision, we will return the vector 3, 0. So now it's time to find out where we can check when the mouse has been clicked to get the collided position, because our goal is to tell the player, please go to that particular position. Once you got the collided position, we are going to create an sphere in order just to check that, okay, we are colliding in that particular point. So we are going to create a primitive that we will destroy fast in a matter of 3 to 4 seconds in order to know, okay, we are colliding in the exact position. So go ahead and do it. And the code should look similar to this. When we are on the player, we are on the state await instructions, we check if the user has pressed the mouse button. If it presses the mouse button, we get the collided position with the position of the mouse, and with this collided position, what we are doing here is just create an sphere and place that sphere in the collided position just to check if the collided position is the right one. And after that, we destroy this sphere after 3 seconds. So let's go to the project. We press play. We go to the free camera state, and on the free camera state, we can proceed to click. Okay, we have missed that when we are on the running state, we are still with the mouse lock. So the change that we are going to do right now is just to unlock the mouse so we can see the mouse when we are on the await instructions. So what we can do is in the camera controller, we can change here the mouse lock. So what we should do is just to, when we are changing both in first person and third person, it's locked, but when we are changing to the free camera, it's unlocked. So now when we go back to the project, just remember to remove the level from the scene, press play, go back to the free camera, and now as you can see we have the mouse and we are creating spheres in the exact place where we are clicking. Okay, so we have everything in place, and now the next step will be to tell the player, please go to the position where we are clicking. So now the final step will be to find out what method of the component navMeshAgent that we have added to the player we should call in order to tell the navMeshAgent to go to the click destination. It's just a line. Access the component and call the method to tell the navMeshAgent to go to the clicked position. So go ahead and do it. And the code should look similar to this. We are accessing to the navigation component and using the method setDestination with the vector3, that is the position where we have clicked. So now if we go to the Unity editor and play, switch to the free camera and select a destination position, as you can see, the player is moving to that destination position. Okay, if we press another one, he will go to the new destination position. The next two exercises that we are going to do is first, we are going to implement the animation for the state await instructions, the animation of the player, because right now it keeps in the idle state, and we are interested that when the navigation component is activated, we want that it transitions the animation from idle to walking. So we are going to implement that. And the second thing that I ask you for you to do is to abstract the functionality of the navigation component to the avatar in order for other elements who inherit from avatar, like the enemy or the NPC, take advantage of the functionality of the navigational component. So go ahead and do it. And the solution should look similar to this. What we have done in the state await instruction for the player, in the update, we are checking if we are going to a target position. That means that the user has pressed the mouse button, has clicked on a position, and we have set a destination using the navigational component. And we keep checking if the distance of the player to the target position is less than 2, then okay, we can change the animation to idle. But if the distance is bigger than 2, then we change the animation to the animation run. In the case that there is no target position, then we would change the animation of the player to the state idle. And to abstract the functionality in order for to move it to the avatar, so elements who inherit from avatar, like the enemy and the NPC, can take advantage of the navigation functionality, we have moved these two members, and we are initializing the navigational component on the start method of the avatar. Okay, Here we are retrieving the component, and what happens is that player is calling the start method from avatar, so it's calling the initialization the same way we were initializing all these components. Okay, so now what we are going to do is to use this navigational component in order to improve the patrol waypoints component. What we are going to do is in the patrol waypoints component, we are going to check if there is a clear path between two waypoints. Okay, if there is a clear path, we go to the next waypoint as always, as we have done so far. But if there is an obstacle in the way, we have to use the navigational component in order to navigate to that waypoint. Okay, so now what I ask you for you to do is that you look for a solution, search this specific thing, and find a solution in order to check if there is an obstacle between two positions. With that information, you will create in the utilities script a function that will be called is there obstacle between positions, and this method will have two parameters, an origin and a destination. And if there is a collision between these two positions, we will return true. If there is not any collision between these two positions, then we will return false. So go ahead and do it, search for this, look for a solution, and implement this function. So go ahead and do it. And the solution should look similar to this. We have created a static function in the utilities script because it's something that we can use in multiple places on the project. And we have calculated first the array. And here we are calculating what layers we should ignore, because we sometimes we will be interested just to ignore some layers and consider others. In this case, we are only just taking into consideration the layers we want to ignore. And with that information, we could prepare the whole thing in order to ignore that specific layers. After that, we can proceed to call physics arraycast with the information we have so far, the array, the hit collision information, and the distance between the two waypoints, the origin to the target. And finally, we provide the layers we want to check. As I said, these are the layers we want to ignore, and we prepare that information in order to provide it here. Okay, so now if there is any collision then between these 2 points, then we will return true. If there is not, we will return false. So now in the patrol waypoints script, we are going to create these private member variables. Okay. And we are going to initialize them on the start. Just after initializing the reference to the navigational component, just check if it's different from null and disable the component. Why we should disable this component at the moment? Because there is some degree of collision with a collider component and an app mesh component. both elements collide between them, and we can get unexpected behavior. So we are interested to disable that component for the moment in order to keep the current behavior. If we go back to the Unity editor and press play, we should check that everything is still working. Okay, let's go here, and as you can see, the enemy is patrolling through the different waypoints, so everything is fine so far. Also, the NPC is patrolling through the different waypoints, so everything is good so far. So now you should find where we can use the method we have just created, is there obstacles between positions, in order to check if there is a free path between two waypoints. Before that, we are going to create together these three constants in the GameController that are the layers that you should ignore. You will use these three constants in order to call this method to ignore these three layers. Okay, first of all, okay, let's go to the code, and in GameController, we are going to declare these three layers. Okay, and now just find out where call this method to check if there is a free path between the two waypoints. Just do it. And the solution should look similar to this. In the exact moment that we are updating the waypoint to the next waypoint, we check if there is an obstacle between the previous waypoint and the next waypoint. In that particular moment, we are using our method, is there obstacles between positions, with the two positions, the previous waypoint and the next waypoint, and with all the layers we want to ignore. Okay? If there is collision, this would be true. And if the patrol waypoints component has the navigation component, it will activate set to true to this Boolean variable. It will enable the navigational component, and it will use the method setDestination to activate the navigational component to move the game object who has attached this component to the destination. So now we need to change the state go to waypoint in order either to use the normal straight movement that we have done so far, or the pathfinding movement. Okay, so in the go to waypoint right here, we need to consider both cases. If there is a straight movement, we will perform as always, as we have done so far. But if the navigation component is activated and running, then we should do it in another way. So think about it and think about what condition you should check in order to decide that when using the navigation component, you have reached the waypoint. So go ahead and do it. And the solution should look similar to this. We are checking the previous Boolean variable that we have activated when there is an obstacle, and we are activating the navigational component with a destination. If this Boolean is not activated, okay, then we are not using the navigational component, we can proceed as always. But if the navigation has been activated, then we need to check if the position of the player is close enough to the next waypoint in order to consider that we have reached that waypoint and we need to proceed to update again. So now back to the Unity editor, we are going to edit the level 0 prefab, so drag it to the scene. And we are going to place a 3D object as an obstacle between two waypoints of an enemy. For the test, I have chosen to do it with this particular enemy. So what you are going to do is just to place an obstacle between two waypoints that involve that there is an action go. Okay? So for example, we are going to choose the transition between the 0 and the 1. So the 1 is this one. I am going to place it right here. I am going to set more time because I think it's 2. So we are going to set the time to 5. And we are going to place an obstacle between these two waypoints. So we can take just a static 3D object, right, just right here. So we make sure that there is no clear point between these two waypoints. Okay, now we should bake again because we have modified the scene with a new object. So we bake again, and okay, now the new wall has been considered for the navigational data. We override the whole thing. And we are almost ready to go. Now we are going to do some changes that I am going to provide the code that are related to what I have mentioned before, that there is a kind of collision between the component collider and the component navmesh agent. So what we are going to do, we are going to disable the physics and the collider when we are using the navigational component. And we are going to re-enable them when we are not using it. So the first thing that you are going to do is this method called activate physics. You are going to place it in the utilities script. Okay, it's a static method, and you place it right here. The next thing that you are going to do in the patrol waypoints component, you are going to add this just on the beginning on the case of the update waypoint. So go to the patrol waypoints, go to the update waypoint, and just right here, what we are doing is that every time that it needs to update the waypoint, we reset the Boolean variable that tells us that we are using or not the navigational component. And if the navigational component is there and it's enabled, we should disable it. Next code that we are going to use, still on the patrol waypoints component, we are going to add this code that is highlighted in red in the change state. Okay, because what we are doing with this code is just activating the physics when we are changing the state of the patrol waypoints. Okay, so go to the patrol waypoints and just right here, activate the physics. The next change that we need to do is on the player. We need to do a similar thing because we are also using the navigational component on player, and we can get some trouble when we switch back and forth between just the normal movement and using the navigational component to move. So what we are going to do is just this. So go to the player, and on the change states, in here, we are going to disable the physics on the state initial and enable in the rest, except in the case of the await instructions, because in the case of the await instructions, we are going to work with the navigational component. One last thing that I have forgotten to do is that for the enemy that is going to use the navigational component, we need to add to the enemy the navigation. So go to the enemy that you have chosen for the test and add the navigation. Okay. This change has to be in the prefab because it will apply to all the instances of that enemy. So now, if we proceed to play and go to check the enemy, as you can see, the enemy, when he's transitioning from that two waypoints, okay, let's check. He's going, and now, as you can see, he hasn't found a direct path, a clear path to the next waypoint, and he's using the navigational data in order to navigate until it reaches the next waypoint. Okay, again. Okay, good. So what another test that we need to do is that, well, do you remember that we implemented the system so we can send our player to different positions? But we need to do the test that if we switch back to the first person camera or the third person camera, we recover the control. And with that last changes that we have done, just disabling and enabling the physics, for the player, the behavior is not broken. So we can switch back and forth between the navigational mode and the first person mode where we have the control.